Hallo, it's Dumplet here. Here's an item on algebra. K is a real number such that x cubed plus x squared minus 16x plus k has two identical linear factors. Find the value of k. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, so taking a look at the condition where this polynomial expression has two identical linear factors, it means that we could factor this into three factors because it is a cubic polynomial. So by the fundamental theorem of algebra, it should have three complex roots. So let's just say the factors are going to be x minus a, and x minus b. So the x minus a and the x minus a, that's going to be the two identical factors. Now, Vieta's formula is going to come into play because we know the roots of the supposed polynomial equation if it's set to 0. So we know the roots are like a, and b. So we should be able to get that, for example, the sum of the roots via Vieta's formula. So the sum of the roots should be negative 1. So negative 1 should be the sum, a plus b. The next, the sum of the roots taken 2 at a time would be negative 16. Going over all possible pairings, a and a, so that's a squared, a and b, and then another a and b. So we should be able to kind of solve the system of equations, this system of equations. So from the first one, we can get a very easy observation that b would be negative 1 minus 2a. So b would be negative 1 minus 2a, and in the second one, a squared plus 2ab would be negative 16. I already have the nice value for b. Let's substitute it in. A squared plus 2a times negative 1 minus 2a. That's going to be equal to negative 16. Let's try to solve for a, and in that, with this, I should be able to get the value of b. So a squared minus 2a minus 4a squared, that's going to be equal to negative 16. So I'll get 3a squared plus 2a minus 16 is equal to 0. I could factor this nicely. So I could factor this into 3a. So factoring is going to give me minus 2 and then a plus 8. Right, so we should be able to have this factoring, and that's going to give me a to be negative 8/3 and a to be 2. Okay, now a is negative 8/3, a is 2. So I have two values for a, that's good. And let's try to get the respective values for b. So if a equals negative 8/3, I would get that b would be equal to negative 1 plus 16 over 3. That's going to become 13 over 3. And then the other value for b, if a equals 2, then b would have to be negative 5. So let me just write down the pairs again. The first pair is going to be a to be negative 8/3. Negative 8/3, while b is 13 over 3. And then the second one, a equals 2 and b equals negative 5. So again, by the use of Vieta's formulas, so by Vieta's, the product of the roots, it's going to be negative k. So negative k would be a squared b, so essentially k would just be negative a squared b. Let's just substitute the values in. In the first case, where a equals negative 8/3 and b equals 13 over 3, that's going to give me negative of 64 over 9 times 13 divided by 3. Now 64 times 13, that's going to give me 832. So 832 over 27. So that's going to become negative 832 over 27, and that's one possible value for k. That's one. That's from the first case here. And then let's try the second case. If a equals 2 and b equals negative 5, so negative of 4 times negative 5. Luckily, we have integers here, so it's a little bit easier to work with. We're going to have k to be 20. So we have two values for k. One is negative 832 over 27. That's already in lowest terms. And then we have k to be 20. And these two will be our final answers. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.